Something's not adding up. A new image has surfaced, and it's shaking the astronomy community. Captured by an independent researcher in Arizona, it shows the mysterious object known as 3I Atlas, shining brighter and moving stranger than ever before. But that's not the only image making noise. Another one, taken by the Mars Reconnaissance Orbiter, has quietly disappeared, and that's where the real story begins. Before we go deeper, make sure you're subscribed, because what you'll hear tonight may redefine how we see interstellar visitors forever.
Reports indicate that the Mars orbiter recorded detailed surface imagery as Atlas crossed roughly 27 million kilometers from the planet. That's close enough for high-precision optical readings, the kind that could reveal surface texture, composition, even faint jets of activity. Yet part of this data, between October 2nd and 3rd, remains sealed. This isn't normal. Usually, Mars orbiter data is publicly released within days. The delay has left scientists and lawmakers asking, what's so sensitive about a comet? NASA eventually addressed it, but not through a scientific statement. Instead, the agency replied to a viral tweet from Kim Kardashian, of all people, saying simply, "No aliens, no threat." That short response, mixed with silence toward actual research requests, created what experts now call an information vacuum. When official voices go quiet, speculation grows loud. Independent astronomers argue that the unreleased Mars images might hold key insights before Atlas exits our solar system forever. This could be humanity's last window to study its true nature. As one astrophysicist said, "You can't call it science if data stays behind locked doors." Transparency isn't just an ideal, it's the foundation of discovery. And right now, that foundation feels shaky. Even tech billionaire Elon Musk weighed in publicly, mentioning that some interstellar bodies can contain high amounts of iron and nickel, valuable industrial metals. But recent spectral data tells a different story. Atlas doesn't just have nickel, it has too much nickel, far more than iron. That ratio is rare, almost impossible to find naturally, because in nature, iron dominates. Nickel, when that pure, suggests something else: refinement.
Let's pause on that point. Nickel, separated cleanly from iron, doesn't just appear, it's made. Producing such a metal in high concentration requires industrial processes, high temperature melting, electrolysis, and complex purification methods. Not the kind of chemistry you expect floating between the stars. So what does that mean? Two possibilities. Either Atlas formed in a region with multiple generations of stellar evolution, making it younger and richer in heavy elements, or part of its material was artificially processed. If that's true, we might not just be looking at a rock, we might be looking at something built, and that's when things start to get uncomfortable.
As Atlas moved deeper into our system, scientists noticed something else. It wasn't following the expected gravitational path, it was accelerating. Now, acceleration in space isn't unheard of. Comets release gas and dust as sunlight heats their icy surfaces, a natural jet effect that can alter their trajectory slightly. But in Atlas's case, the numbers didn't match. For its observed motion, it would have needed to lose around 1/6 of its mass in a matter of weeks. That's billions of tons, enough to create a massive glowing debris cloud visible from multiple observatories. Yet, no such cloud exists. Atlas is moving, but not losing mass, and no known natural mechanism can fully explain that. Could it be some unknown natural process, or something else? Maybe even controlled propulsion? That's the question haunting researchers right now. Even stranger, Atlas's path through the solar system seems too precise. It passed near Mars, then Venus, then Jupiter, aligning perfectly along the ecliptic plane, the same flat disk on which all major planets orbit. That's an extremely rare coincidence for an interstellar visitor. Most arrive from random directions, crossing the solar system at steep angles. But Atlas? It's moving almost perfectly along the planetary plane, retrograde, against the normal direction of orbit. Mathematically, that's less than a 3% chance if it were random. It's as if it deliberately aimed for this path. Was it coincidence or navigation? Between July and August, Atlas did something even more bizarre. It produced a jet aimed directly at the sun. Normally, radiation pressure from a star pushes a comet's tail away, forming that classic anti-solar shape. But Atlas's jet was reversed, moving against the solar wind, a phenomenon that defies every cometary model on record. To create that effect naturally would require a force stronger than solar radiation. So far, none has been identified. This sunward jet has fueled debates about whether Atlas might be actively maneuvering using unknown energy processes or propulsion physics far beyond human technology. And then comes another paradox. Atlas isn't small. Its nucleus is believed to be 1,000,000 times more massive than the first interstellar object, Oumuamua, yet it's traveling faster. In the universe, mass and speed follow predictable rules. Heavy objects tend to move slower unless acted upon by external energy. So either Atlas came from an extreme gravitational slingshot event, or it had help, some kind of initial power source that boosted its motion long before it reached us. Imagine a freight train outrunning a race car. That's how unusual its behavior looks on paper.
The list of Atlas's oddities keeps growing. First, a retrograde orbit lined up perfectly with the ecliptic, almost impossible by chance. Then, a jet pointing straight at the sun, against all physics we know. Its mass and speed don't add up. Heavier than other interstellar objects, but moving faster. High nickel content, almost industrial level, not what we usually see in space. Mars data, locked and silent. No debris, even though physics says there should be a massive cloud. Optical reflections unlike any comet ever seen. And a link to the 1977 WOW signal region. A weird cosmic coincidence. One of these alone is strange. Together, it's a pattern science can't ignore. Let's pause on that last one. The region Atlas entered our solar system from lies just 9 degrees away from the source of the legendary WOW signal, a 72-second radio transmission detected by SETI back in 1977, still considered the strongest candidate for an extraterrestrial message. A coincidence? Possibly. But after decades of silence from the stars, having a mysterious object emerge from nearly the same direction is more than enough to spark new debate. As Atlas neared the sun, telescopes recorded another anomaly. It didn't just brighten, it turned blue, bluer than our own star in certain wavelengths. Typically, comets grow redder as dust scatters light. Atlas, however, shifted the opposite way, implying either unusual reflective material or energy emissions we don't yet understand. Some researchers suggested exotic surface compounds. Others whispered energy field. No confirmation yet, but the evidence keeps piling up. The next big observation window opens between late November and January. Atlas will make its closest approach to Earth on December 19, 2025. Observatories around the world will be watching closely, looking for any debris clouds, jet activity, metal signatures, or something completely unexpected. Meanwhile, the pressure on NASA is growing. Scientists and lawmakers are demanding the Mars orbiter images. If those pictures exist, they could finally show Atlas's shape and structure, revealing if it's just a strange comet or something far more unusual. Science advances through transparency. Data must flow freely for independent verification. That's what keeps discovery honest. But when information gets delayed, trust erodes. And in that silence, rumors find space to grow. Some see a natural phenomenon we just don't understand yet. Others suspect something technological, a probe, a fragment, maybe even a remnant of another civilization's history. Whatever the truth, 3i Atlas forces us to confront how little we truly know about what drifts between the stars. We began with a leaked image and ended standing at the edge of one of the biggest astronomical mysteries of our time. Atlas defies the rules, from its metals to its movement to its silence. It might be natural, it might not, but either way, it's rewriting what we thought possible. In the coming weeks, the world will be watching. Will we finally get the Mars data? Will the December flyby reveal the truth? Or will Atlas vanish into the dark, leaving more questions than answers? Stay tuned, because the next chapter could change everything. If you found this report thought-provoking, share it. Subscribe to Grandpa Cosmos, because next time we'll explore what could be waiting beyond Atlas and why some scientists think our next visitor might not be silent at all.